this lesson, we're going to talk about the distance formula, and as you can see on the screen, learning targets for today is you're going to be able to calculate the distance between 2 points on the coordinate plane. That's our first one. And the second one is you're going to be able to calculate the value of a missing coordinate when you're given a point and just part of another point and the distance in between those 2 points. Now, this first slide I have here, I just have a couple of examples or 3 examples going back to calculating the missing side in a right triangle. Now, in these first 2, I'm just going to give you the answers. So if you want to practice that and see how you did, go ahead, pause the video right now, and then unpause it, and I'll have the answers for these first 2 examples. So for this first one, the length of h comes out to be the square root of 193 feet. And my second one, the length of r, is equal to 45 inches. Now, my third example, this one I'd like to take a look at. We have a right triangle. We can see that when we look at it right here on the coordinate grid, vertical and horizontal sides. I'm going to make a right angle right there. Now, in order for us to find, if I said I wanted to calculate the length of the hypotenuse in this right triangle, I'm going to call it h, what would we need to know? Well, we need to know the length of our 2 missing sides. So on this, most of you are going to look at this and go, well, if I wanted to figure out the length of that side, I could count it, which, yes, by all means you could. I also look at this and go, what if it's not so easy to count? In that case, then you're going to want to look at, well, what are the coordinates at these points? So I'm going to start off up here on this one. The coordinates at that point are at 7, 5. The coordinates at the one down here in the bottom, those coordinates are at 7, -3. Now, if I wanted to figure out how far it was in between those 2 points, which is the side of my right triangle, I could just take a look at this value and this value, and I could just subtract them. Well, 5 minus -3, that puts us at 8, which would be the same thing as when you counted those side lengths. Now, we also need this length right here. Well, we can do the same thing. You could count it, by all means. But I also look at it and go, when it's not easy to count, I'm going to need this coordinate right here, and that one is out here at -8, -3. So if I wanted to figure out the length of that side, now I'm going to need to look at, let's go with this color. I'm going to need to look at my x values, this one and this one, and go, well, how far is it in between -8 and 7? If I, again, subtract them, I end up with 15. So I have those 2 sides now in my right triangle, and now I can calculate the length of that hypotenuse by using the Pythagorean Theorem. So I go back and I'm going to call 15 my A. So we have 15. We then have to square it, add on our B, which in this case is 8, and then square it, and it's going to equal h, our hypotenuse, squared, which a lot of times we use C for that one, but in this case I'm just going to call it h because that's what I labeled it right here. So now as we go through and solve this, 15 squared is 225, our 8 squared is 64. If I add those 2 together, I end up with 289 equal to our h squared, and then I'm going to finish it out by, oops, I don't need that, taking the square root of both sides, and we find out that h equals, now remember, if you're solving the equation, we have to look at the positive and the negative in this situation. Well, since we're working with our right triangle, we know that that side can't be negative, so in the end, our hypotenuse is 17. Now that brings me here. What if I want to calculate the length of the hypotenuse of this right triangle? It goes back to a little bit of what we just did on that previous slide. So I'm going to come here and I'm going to call this h, that's what we're looking for. Which, you know what, I'm actually going to rename that. We're going to call that, so it kind of goes back and it looks more like our Pythagorean theorem, I'm going to call it C. It doesn't really matter what variable we use, but in this case, I'm going to use the C. Now, if I'm going to use the Pythagorean theorem, I need to figure out, well, how long is A and how long is B? Now remember from the previous slide, we used the coordinates at this point, and this point, and this point. Well, two of them we already have. It's this third one that we don't have right now. But if I look at this, the x value is going to be the same as the x value up here. So that's going to be at x2, comma, and the y value at that point is going to be the same as the y value right here, and that's y1. So now I can figure out how long b is by looking at the x values. And if I want to find the distance in between 2 points, I just subtract those x values. So I'm going to take x2 minus x1. And there is the length of my b. For my a, I just have to look at my y values. Well, y value here, and if I subtract those, I end up with y2 minus y1. So I now have the length of two of the sides of my right triangle. So now I go back to the Pythagorean theorem. A squared, well in this case, my a is y2 minus y1. So I have to square that, remember. Pythagorean theorem says a and then square it. Plus, now I have to have b. Well, my b in this case is x2 minus x1. And then I have to, oops, wrong color. I have to square it, and that's going to equal the hypotenuse, which is c, but then I have to square it. Now you ask yourself, well, how am I going to solve this for c, which is the hypotenuse? Well, this goes back to solving our equations that are squared. One method to do that, remember, is to take the square root of both sides. So if I were to take the square root of c squared, that's going to give me an answer of c. Well, if I take the square root of the right side, I also have to take the square root of the left side. Well, when I look at that, I'm just going to end up with this all over again. y2 minus y1 squared plus x2 minus x1 squared. And remember, when I take the square root in an equation, I always have to look at the positive and the negative. Now, there's a little bit that I'm going to manipulate with this. I'm going to look at this and go, well, c is the length of a side in my right triangle. So the negative part right here doesn't really make sense. So I'm going to get rid of that part and then just look at it as the square root. And now here, just for the sake of making it look like it does all the other times when you're talking math, I'm going to put the x's first, so then it'd be x2 minus x1 squared plus y2 minus y1 squared equal to, and now it says c, but here's the thing. I'm going to change that to a d, because what we've just discovered right here is the distance formula. Right there. Because yes, I know we said we were finding the length of the hypotenuse of our right triangle. But if I'm looking at the length of that side of the triangle, that's no different than the distance in between those 2 points. So I found the distance in between those 2 points using the coordinates, and I now have a formula right here that you're going to want to remember. Now here's where that formula comes in handy. In this problem, I want to calculate the exact distance and the approximate distance rounded to the nearest hundredth between these 2 points. So I go, well, if I'm trying to calculate the distance in between 2 points, let's use the distance formula, which is right there. So now it's just a matter of plugging in our points. I'm going to call this my second point, and I'm going to call this my first point. So we just come down here, we start plugging numbers in. Well, x2 is 5, y2 is 4, x1 is -3, and y1 is 8. So I plugged the numbers in, now it's just a matter of getting all the math symbols. So we have our equals, the square root So we have x1 minus, or excuse me, x2 minus x1, we have to square it, plus now we have y2 minus y1, and we have to square that one. Now we just simplify what I refer to as the mess. 5 minus negative 3 puts us at 8, we have to square it. 4 minus 8 puts us at negative 4, we have to square it, square root. And we just keep simplifying this. So now we're at 64 plus 16. Still have the square root. And I keep writing that down every single time so I don't forget about it. Sometimes I see students do that. Add those together, we get 80. Now if I have to simplify this, I would look at this and I would, to me, I prime factorize it. Prime factors of 80, well, I look at 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. Then I see a pair of 2's here. That's going to bring a 2 on the outside. It's going to bring another 2 to the outside. So I end up with 4. I still have that 5 there. So 4 root 5. Oops. This would be my exact value of 4 root 5. Exact. If I wanted the approximate, remember it's asked for the approximate. Now when I type 4 root 5 on my calculator, or the square root of 80, I get 8.944. But this problem asked me to round to the nearest hundredth, so then I would just leave it as 8.94. So there's our approximate value, and here is our exact value. All right, one more problem that I wanted to look at. Now this one's a little bit different because notice in this one we're given 1 point, we're given part of another point, and we're given the distance in between those 2 points right here. And we want to know, where is that second point? In other words, what's the x value there? So here's what I've done. I've looked at it. If I graph it, it looks like this. Now I know I have a circle here, but notice I have my first point in the red. Now my second point, I don't know where that's at because I don't know the x value, but I do know that it's 5 units away from the center. So 5 units away from that red point is any one of those points that's on the blue. So I have to figure out where it is. Well, here's what we do. We go back and go distance formula. It will work. It will help us here. We just start plugging in what we know. So I look at this and go D. I know that my 2 points are 5 units apart. Equals, and now I have the square root of all this. Well, x2, do I know that? I don't. That's my a value. So I put a in there. And then we're back to minus x1 value. I know that. That's 2. Put it in. Plus y2, do I know that? I do know that one. It's negative 4. Minus my y1 value. Do I know it? Yep, it's negative 1. And now we have an equation to solve. So here I go. I just start simplifying things. 5 is equal to, well, there's nothing to do here. So I still have a minus 2 squared plus, but this is going to come out to be negative 3 squared. Keep going. And I'll have 5 equal to the square root of this. Still have this as a minus 2 squared plus, this is going to turn out to be 9. Now, there's multiple routes that we could take from here, but I'm going to look at this and go, I have a radical equation. And remember, when we had our radical equations, a way to solve this is to get the radical all by itself, which we have, and then we can square both sides. So when I do that, 25 equal to, now I have a minus 2 squared plus 9. Well, I have a quadratic here. I'm going to have to take this binomial and FOIL it, square it. So then I'm going to end up with, this is going to turn out to be a squared minus 2a minus 2a plus 4. That's just this part, but then I still have the plus 9 equal to 25. Well, I know this is a quadratic equation, and when I solve a quadratic, I like everything to be on one side, so one side's equal to 0. So what I'm going to do right now is I'm going to subtract the 25 from both sides. So I have the left side equal to 0, and my right side's going to have everything else. So now I have 0 equal to a squared. This comes out to be minus 4a. And then I have plus 4 plus 9. I'm at 13. And 13 minus 12, or minus 25, should put me at minus 12. I notice that this one is factorable, so I'm going to solve it by factoring. Come up with my factors. I end up with a minus 6 and a plus 2 equal to 0. Let's set each one of those factors equal to 0. And now solve these two little equations. Oops, typo. Add 6. We have a equal to 6. And a equal to negative 2. So really there's two answers according to my equation, but then I come back up here to my problem and I look at the question, and notice it tells me that my point is in the quadrant 3. So I come over here and I look for quadrant 3. Well, 1, 2, 3. So my point has to be over here, which tells me that I have to have a negative x value. And my y value, remember, was negative 4. So that's the point right there, which brings me down here and goes, well, that has to be, this is my answer to that x value that we were missing. It's negative 2 because the 6 would put us into the fourth quadrant. So this is an extraneous solution in this case. My answer is right there. Just a reminder, our learning targets were there. We went through examples to help you with both of those. Like always, let me know if you have any questions.